Welcome back to the second section of the new statistics, estimation and research integrity. Thank you for joining me. Research integrity and the new statistics. Isn't this a title to die for? Why most published research findings are false. A famous paper by John Ioannidis, getting on for 10 years ago now. And this reflects a real crisis across many areas in science, the replication crisis. All of a sudden, across many areas, people have been re-examining some results that were published in the literature, seen to be well accepted, but couldn't replicate, from cancer research, social psychology, many other fields. And this is a disaster. This is terrible because this is science. This is what is in the journals and what we rely on to guide our professional practice, to do our medical treatments. And so, of course, science advances by identifying and correcting error. But this is more serious than that some of the fundamental findings out there just couldn't be replicated. And Ioannidis put forward an argument that there are three aspects to this problem. One is selective publication, another is tweaking and selecting and fiddling until p-value is sufficiently small, and then lack of replication. We don't have journals, we don't have the tradition, we don't have the incentives to repeat an experiment. Oh, I got the same result, ho hum, but in fact that's very important in science. And Ioannidis identified the imperative to achieve 0.05 as underlying all these three. It's very nice that this came from medicine, not just within psychology, but these arguments are very applicable in psychology and, in fact, across many disciplines. And so he's saying that, well, if many false positives are published, spurious results, then many published findings are false. An important contribution was that of Simmons and Co., False Positive Psychology, focusing on question 2 and giving it the label p-hacking. And they argued that, well, in fact, there are lots of points at which we have freedom to tweak a little. Now, we're not talking fraud here, we're just saying, well, ways to get clarity. When we look at our data, I mean, we're trying to find the clear patterns. There's something there, we just have to reveal it. Test a few extra participants, drop or add a dependent variable, choose which comparisons, drop a few clear outliers, try a few analysis techniques, and then choose which to report. The statisticians have a saying that if you torture the data for long enough, they will confess. And if there are many degrees of freedom here, well then basically you could possibly start with random numbers and still find yourself a p-value less than 0.05 at some point. A little bit of a complicated argument to follow on the way through, but sort of 3 steps. If we've got low power studies, then and only statistically significant results are published, then maybe an inflated proportion. We'd expect an inflated proportion of results that were published, that were significant, to be actually false, to be type 1 errors. If we add in p-hacking, that means that a lot of the truly non-significant results become spuriously significant, these red ones, and so we have an even larger proportion of the results that are published as significant that should not be, that are false positives. And then third, if we have journals that selectively look for surprise, for novelty, for results that we didn't expect, well then we'll probably selectively publish the red things, the p-hacked things. And so Ioannidis claiming that half are false, I mean, might even be accurate, which is a terribly frightening thought. So what do we do about it? We have these 3 problems, with p-values underlying all 3. Well, I'm proposing the term research integrity as a label for this whole set of concerns, with the first meaning of the completeness and validity, the trustworthiness of published research literature. We want the literature that's out there in the journals to be valid so that we can rely on it. And for that, we really need to solve all three problems. But there's a second meaning of research integrity, which is the ethically or morally correct behaviour of researchers. And so researchers have to do a number of things, including complete reporting, complete disclosure of every step and every variable, and every time you dropped out a few things. Be very aware of p-hacking risks and avoid them. Carry out replications, and if you carry out research to a reasonable standard, the results should be made publicly available somehow. The decision to publish or not should be based on the quality of the research, not the nature of the outcome, because otherwise we'll have selective publication based on particular results, which will give us something other than full research integrity, a full, complete reporting of all relevant information. Now, psychologists know that, of course, that it's useless simply to say, come on, children, all be better. You've got to not be so naughty, just do good things. We know that if we want to change people's behaviour in a good way, it's not just a matter of exhortation and explanation, but we need to provide an incentive structure. We need to show that the social norms are that everybody is doing it. We need to provide mechanisms to make it as easy as possible. We need to provide sanctions and structures and expectations to help guide. And that's what a lot of people are working on at the moment, which is terrific. Well, where does new statistics come in? Following the question, well, if we adopted the new statistics, would that help with our research integrity questions? It would, in some ways it would. It would remove the imperative to achieve statistical significance in order to get publication. It would remove the dichotomous mindset that a thing replicates or it doesn't, or you got an effect or there's no effect. It would be more nuanced, more quantitative. And the estimation on meta-analysis, we need a number of studies that we can integrate the evidence from, stresses the importance of accumulation and replication and a number of studies triangulating in on a particular issue rather than just a single study being the full answer. And that, of course, means that all results need to be made available. So these are ways in which the new statistics can certainly contribute. But it certainly won't solve all problems. For example, there'll still be the career imperative to get stuff into the best journals. There's still every possibility that you can select your data and tweak your analyses and do a whole lot of things and just report a few things if you use estimation. So the new statistics does not fully solve that question. And journals' preference, if they continue for novel and exciting different findings, well, that may well continue. So what we need for research integrity is understanding the three problems. I mean, our discipline does research of an immensely interesting and impressive range of types. We have longitudinal studies that go for decades. We look at brain scans, we look at big data, we do enormous computer simulations, we do lots of qualitative stuff with videos and field observations. We can't possibly pretend that a few simple rules will cover all that vast richness in telling us how we should improve our practices to solve these three problems. And so we really need all of us to understand these problems deeply so that we can grapple with them and figure out in our own situations how we should best proceed and minimise the risks. It's easy to say, well, yes, we need the new statistics. I would say that, wouldn't I? And we need more informative experiments that will be more detailed and give us better outcomes. One thing we need to think about is a clear distinction between exploration and pre-specified experiments that we can really rely on. And traditionally in our research, you've chosen an issue and you do some experiments and they don't quite work, so you modify a bit, and eventually say, ah, yes, here's one that worked, right, here we go, very strong. But we don't know to what extent you're capitalising on chance. And so what we need to do is adopt practice that, okay, pilot exploration is terrific and great fun often, but the results that come out of it are speculative. They're pretty sure not to be publishable, but they give us guidance. And once we've digested that guidance and used it to plan what we think will be a good experiment to investigate that issue, then we pre-specify that. And that's the strongest guarantee that we're not going to p-hack or drop a couple of variables or test a few more subjects. So we pre-specify and say, I'm going to do a study using this procedure and these participants and analyse in the following way and report these measures. Then you go and do it. And then you're duty-bound to make the results available in some way to future meta-analysts, whatever they are. Even if you think they're terribly boring and disappointing, they've got to be out there. So we need mechanisms to encourage this and make it easy. We need ways to publish data in some form, whatever the results. And ethical review boards need to take these new things into their stride, and perhaps as part of the process of getting ethics approval for certain studies, particularly experimental work, you should be required to propose that you will pre-register. You'll explore, then you'll pre-register. And then you'll make the data, the results, available no matter what they are. We need mechanisms to encourage replications, to reward replications, to recognise their value. And so all these things, achieving these things, requires resources, guidelines, expectation training, journals with revised editorial policies, and so on. And in fact, there's some terrifically interesting discussions going on, particularly in psychological science, and particularly in the last 2, 3, 4, 5 years. And for example, in the APS journal Perspectives, year before last and last year, a whole lot of papers relevant to this. I'll mention just a couple of points. Replications, maybe students should do them. On the other hand, maybe that makes them sort of B-grade sorts of things. It's still just very challenging to do good replication. And Ioannidis himself, writing a paper, felt he had to write a paper reminding us that, you know, in science, we want to get at the truth. We want to understand the universe. And so we should build into our thinking and our methods honour and recognition for getting at the truth. Now, this doesn't exactly tell us how to do our statistics, but it's very different from thinking about, I've got to get 05. This is really the touchstone that we should be aiming for. And the thing that I particularly like, a paper reminding us that, well, and psychologists have for many years have been doing this often very well, ingenuity. Can we dream up very clever, ingenious experiments that can sneak up on these tricky effects we're studying in a novel way that really throws light on them, and preferably converging evidence, so studies that will come at it from a number of different angles and give us a good picture. A few of the projects going on, and I'm sure some of you are involved in these, know perhaps more about them than I do, but the Centre for Open Science runs the Open Science Framework, which is an open source software environment, plus other goodies, to help researchers document and organise and manage research projects, even if they're spread out around the world, and to declare, when they choose particular procedures and protocols, to do analyses, to record analyses and record data sets, and at certain stages to make this public. So this is an environment, a resource to facilitate good behaviour. All very much in progress and in development, but making very encouraging moves. Reproduction, replication, some initiatives to get replication going, with people all around the world coming in with high standards, and then guarantee that if you do the right thing, the results, whatever they are, will contribute to the final meta-analysis and will be published. And in Perspectives, that same journal, this possibility of publishing these replication reports. And various resources that allow you to upload, to make public your results, even if they didn't seem terribly exciting. And this is not just psychology. Right across science, there are discussions along these lines and tools and resources being proposed to facilitate this enhancement of research integrity. Just very recently, in the May 2014 issue of Psychological Science, Perspectives on Psychological Science, we have discussions, for example, that gives a central place to the p-value. I didn't find it enormously convincing myself, but that was just my bias. Written about with great insight and making proposals for new ways to think about studies to extract more information from them and make better judgments, better assessments of how good they are. Data peaking, this idea that we can test for a bit, have a look, oh, need to test a bit more, well, and go on testing more and more. It's quite possible to justify that if you allow for the fact that you've looked along the way. A couple of papers very dear to my heart about meta-analysis, and this proposal of the term adopt a meta-analytic mindset. Well, fine, I agree totally. Sue Finch and I think in 2001, we might have introduced the term, we certainly used the term of meta-analytic thinking, the same sort of idea. That any experiment you do, you need to think about in the context of what's come before and what is likely to or could or should come in the future. And think of your study as a brick on the wall building towards this meta-analytic integration. And so you will, at the very least, report your study in a way that facilitates it being included in future meta-analyses. And here we are, Rosenthal, who's been in this game for longer than just about anyone else, continuously accumulating meta-analysis. It's not just a one-off thing, but every time a new relevant study comes along, we build up the meta-analysis a little more. So these are just examples of some of the contributions to current discussions towards achieving research integrity. Journals are making strides here, the Psychonomic Society with new guidelines, Social and Personality Psych with new guidelines and recommendations, and perhaps biggest and best, Psychological Science, beginning of this year, new guidelines with Eric Ike, who's at this convention, setting forward in this editorial the new requirements from January this year for authors who wish to publish in Psychological Science. And this is really a groundbreaking set of steps. One of them, one of the sets of requirements is enhanced reporting of methods. So you have to declare that if you excluded any data or any groups or anything, you tell us. That you've told us about all the manipulations, all the measures, how you selected sample size and so on. And okay, you might have reasons for dropping things, but you've got to be open about it and declare it. You have the possibility of earning up to 3 badges, and we hope that these will become the source of great kudos and sought after. And then of most central interest from my perspective is embracing the new statistics. So it's not compulsory to shoot every p-value, but a strong encouragement to use estimation whenever that makes sense, whenever you can, and publish this tutorial article of mine that in a way is sort of an expansion of this workshop. And APS is totally open about this, not claiming it's got everything right first up, wanting lots of contributions, and very keen for other journals and societies to develop along similar lines. So here are the OSF badges, pre-registering your study. Haven't seen too many of those yet, but just beginning to be some badges coming out in Psychological Science for people who have all their materials uploaded so other people can use them, and their data similarly. This is the tutorial article, which is a free download from this link. Statistical reform, well, some of us have been in this game for a while and followed it, and we have to recognise that reforming statistical practices, we're standing on the shoulders of giants. Back since the middle of last century, Paul Beale and Jacob Cohen and other big names have been publishing swinging critiques of NHST, and there's hardly been any reply. Very few people saying, hey, wait a minute, that's great. Fiona Fiddler told the full story in her PhD. A brief story I summarised in the APS Observer, March in 2014. The medical fraternity made big steps in the 90s, to some extent prompted by Ken Rothman, a noted epidemiologist, and he went to the extent of founding a new journal, Epidemiology. For 10 years he edited it, and it didn't publish any p-values. It is possible to do excellent science and for a journal to flourish without a single p-value. Geoff Loftus at Memory and Cognition in the mid-90s came into the editorship aiming to improve statistical practices, and he wanted figures with error bars and no p-values. And he was quite successful while he was in the chair, although people could not give up their p-values. They gave the error bars and would use them, but as soon as Loftus left, the practices slid away again. The publication manual now in 2010, the latest edition, has a format for the first time for reporting confidence intervals and lots and lots of examples of confidence intervals in tables and in text and so on. So this 60 years critique of NHST, summarised very ably by Rex Klein in this chapter, which is now a free download, the 13 severe NHST problems. Over the last 20 or 30 years, meta-analysis has arrived and in fact been accepted quite widely in our discipline, and that's excellent. Now, it doesn't need p-values. In fact, p-values are some of the main things that distort and produce bias in meta-analysis. So some of us were hoping that meta-analysis coming along would be the prompt for p-values just quietly die away. Didn't happen. But now we have the replication crisis. All of a sudden, it is urgent that we re-examine these things, take the Ioannidis argument to heart, and I just wonder whether we might be at a tipping point. That would be wonderful. Psychology struggles out of the pea swamp into the beautiful garden. Well, I wonder. So, summarising the first two sections, p-values are unreliable in the sense that do it again and you're very likely to give a very different answer. And they only give us illusory certainty tied in with this dichotomous significance testing, whereas confidence intervals are more informative. Estimation is what we need for a quantitative discipline that's cumulative. And now the replicability crisis demands change, research integrity. We've got to really grapple with that. We don't know the answers yet. The APA publication manual sort of legitimates changing. It's an imprimatur that estimation's a good thing, and now we've got psychological science leading. And so research integrity, NHST, the researcher's heroine. Can we kick the habit? Can we let somebody tear it away from us? You know, the trouble with P, they bounce all over the place. So, can we trust P? I suggest we can't. So that's sort of summarising the new statistics why, and it's your turn. Would you care to ask questions? Maybe we can squeeze in 3.
Thank you for this part of the talk. I'm wondering, where do we start this change in daily practice? I can imagine if you work in an environment as a graduate student and you want to implement these changes, and your advisors and your research environment says, well, no, we're sticking to the way we're used to. How do we
Absolutely right.
start?
Yes. And I mean, I have to get my papers published, my students have to get their dissertations passed just like everyone else, and so we grapple with these things. And numerous times I've sat in the coffee room and somebody's come up to me and said, look, Geoff, I gave them all that stuff and effect sizes and things, and the editor says, chuck all that out, tell me what the stars are. What am I going to do? Well, I have a slide about this later, but let me just summarise. As scientists, our responsibility is best practice. And so we have to decide what is best practice, and if we're convinced we should change, we should persist and stick to it and argue for it. And this actually is becoming easier day by day, because when you've got the publication manual legitimating it, when you've got psychological science embracing it, it's not quite so left field to say, well, look, I'm going to do this. I think it's very good strategy to spend a little bit of time, maybe a couple of sentences in an article, maybe a page in a dissertation, explaining your data analytics strategy, giving a few references, and justifying it, giving reasons why it's a good thing to do, then follow it through. And even if that would not have been the first choice of strategy for your reviewer or your examiner, they should be able to respect the fact that you understand the issues and you've made a conscious choice for good reasons, and then you followed through. I think another reason is that for estimation, there are now many more resources than there were. It's much more possible than it used to be. Not pretending we've got everything solved, but even dealing with higher order interactions or multivariate sorts of things, there are many more possibilities to get estimation information. We need to develop our customs and our ability to do that, and we'll talk about that more shortly, but that really gets to the heart of it, a very practical thing. Let's have just one more quick question. Yeah.
I was wondering, in most papers there's going to be a discussion section where you put your results in context, and quite often showing that this is a step forward, but it's consistent with previous findings. Could you comment on that as a quasi-potential kind of meta-analytic thinking?
Yeah. One of the things we'll discover as we go through is that I'm advocating interpreting confidence intervals and effect sizes, and that of course has a subjective element, and I don't think we should apologise for that or shy away from that. And so in discussing, absolutely right, we should discuss our findings in the context of previous findings and looking forward to what might come next. A thing I'll say about meta-analysis is that the minimum number of studies you need to do a meta-analysis is 2. We've published a couple of articles where we've meta-analysed 3 studies, 3 findings from related little experiments. And so if a quantitative meta-analysis makes sense as part of this integrative discussion, then do so. But absolutely right, that this sort of discussion we can think of in a meta-analytic way. So the next is the big one. We need a sort of trumpet fanfare, I think, to announce it in a minute. So the next section will be confidence intervals, but meanwhile, thank you very much for your attention for these first 2 sections.